So, hi everybody. So, today we are here to discuss this next question that we are having is that shuffle a deck of cards. So, what actually we have in this is we're given a function that generates perfectly random numbers between 1 to k, where k is input, and write a function that shuffle the deck of cards represented as an array only using swaps. It should run in O of n time. Hint, make sure each of the 52 permutations of the deck is equally likely. So before I move on to the solution, would anybody like to tell, because this is a simple question, you can just uh, tell me your thought process that what you are thinking that how we are going to solve this. Anybody on this? Anybody who can tell that how we will be solving this, or what would be the approach?
I want to clarify my understanding of question first. So I have 52 cards.
Yes.
Um, so let's say they are aligned in a linear fashion.
Yeah.
Given a k, let's say I'm being given k equal to 5. So that means I have to shuffle 5 cards. Is that what it meant?
Yes. So you are having an
Random 5 cards.
array of 52 cards. So now you have to shuffle them randomly, and K is the number. So how many number of cards you actually want to shuffle out of these 52 cards? So here we have to shuffle all the cards. So this line which is here is this tells us that we already have a function which generates a number between 1 to k. So this is what is given
So
below.
we can freeze k. Basically, they're going to give a k input to us, right? I check the function. That's how they've given it.
Yeah, this is about the random function that is already there in Java, that we already have a function that generates perfectly random numbers between 1 to k. Now we have to use this function to shuffle the deck of cards.
Okay.
So
Okay.
this 1 to k is the input for that function which generates a random number. All right.
Okay, so there are 52 cards. So at each position, that's why it is 52 factorial, because first position can be filled by 52 card,
Yes.
second can be filled by 51. That's what it is.
So how can we solve this in O of n time? So before O of n time, can anybody tell any other solution?
Here, shuffling the cards to be of k times, or like we need to shuffle the cards just like that, or like we need to shuffle the cards like k number of times.
No, we
Is
have
that
to
what it
shuffle
is?
the cards once. This is about a function that we are having a random function. We give to it input of, in this case, we'll give input of 52. So it will generate number between 1 to 52. So this is what line 1 is telling us. So we are already given a function which generates perfectly random numbers between 1 to k, where k we will provide to that function. And using this function random, we have to make some other function, that is shuffle, in which we have to shuffle the cards that we are having in an array from 0 to 51 index. So this is what we are told.
Ashmit, is it like permutations problem that we solve using backtracking?
What?
Is it like permutations problem that we solve? We have.
It's a design problem. You can use any of the approach which of you want, but here the solution which we want is in we need it in O of n time. So backtracking won't be efficient in that case. You need to think something else. So we are already having, suppose, 1, 2, 3, 4, 5 till 52. So this is the initial array that we are having some cards, 52 cards, and their position is given, that is 1, 2, 3, 4 in this array. Now we need to shuffle them so that in after shuffling, here suppose we have any random number, that is 5, 3, 1, 6, and these numbers should not be repeated so that the shuffling is correct. So now anybody? Akshit, algo is known as Fisher-Yates. Yup, exactly. So, can you please explain that what we do in that algo, in Fisher-Yates algo? Akshit. So, select a random number in range 1 to k. Okay, so let us proceed. So, first of all, I would like to discuss a simple solution in which we can create a separate single array. Let us create a string array of similar size, that is of this dex, that is 52 size. So this is also array of 52 size. Initially, all the values are filled with 0. So what we are going to do next is we are going to use a random function which will which by using which we can select values from this initial array. Suppose that random function will be generating values 0 to 52. So this random function gives us the index. Suppose in the first when we run this first time, it gives us 23. So whatever number is at 23 index, that will first fill up in the first index. And again, we go for the random function. So next time, maybe it generates like 34. So we'll again check that index. And if that index is already not selected, then we'll put that number in the second index. So we can keep on doing this till this array is filled. So none of the numbers will be repeated. And even we can have totally random numbers at each of the position. So this is one of the methods in which we are using a separate array, and we are generating numbers to select the index, which we just keep on appending to a new list that we just created. So is it all right? How this?
One question. So, like I have to do the case swap exactly, right?
Yeah, in this case,
Yeah.
no, you are just filling the values here. Initially, this array is empty.
No, what I'm saying is the solution. Is it the one that you discussed the solution to the problem?
Yes,
So, okay. So my question is, so you're saying I will call a random number, I will fill a random number. That's okay. How many times will I make the call? K times?
yes. This is not the algo in O of n time.
No,
First,
no, no. That's okay. I
yes,
want to understand what we are doing here. Is it the solution to the current problem?
random number I'll be generating till this whole new array is filled.
If you call the random number for to fill the complete array, how will I make sure that there are only k swaps?
We don't need key swaps in this.
Wait, 1 second. Can you
Actually,
show me the problem once again?
yes, it's here.
Write a function that generates perfectly random number. Oh, given a function, write a function that shuffle a deck of cards represented using only swaps. So why the k is given then?
K is the input for this random function that we are using. This here 52 is K. This is generating numbers between 1 to K.
Can you take example with just 10 numbers? I still want to understand what's going on.
And one more thing, Ashwin.
Yes.
So here, like while inserting the values in the new array,
Yes.
so we need to check for the, say, the random function will generate a unique numbers only, or it will generate the same numbers again and
If
again.
it generates the same number, then we'll again call the random function.
Okay, we need to
This
check
is a
whether the
brute
element
force,
is
that
present
is,
in that one or not.
we can call it as a brute force solution because that is not in O of linear time. So I'll discuss the Fisher-Yates algo just after this.
Yeah.
So with 10 numbers, what we are going to do is, suppose we are having an array from index 0 to 9, and the initial we can say values are 1, 2, 3, 4 till 10. All right. So first line that is given in a question, that is given a function that generates perfectly random numbers between 1 to k. That function is already given to us, that is random. Its input is k, that we are going to provide to this particular function. So yeah. So here we have a k. K is this input which we will be providing to this random function, and this function will generate a random number between 1 to k. All right. So in this case, what we'll be doing is for swapping. So we have created a new array. So we'll use this function to
Let's say, okay, let's say my k is 4.
No, why will I choose my k equal to 4?
No, just to take an example, I want to make sure that my understanding is correct.
Okay, so if my k is 4 in this case,
I understood that you can take any k because random number will generate between that range. I understood that completely.
yes.
I want to know if you take k equal to 4, so what are you doing after that? That's what I.
So this number this random function will keep on generating numbers between 1 to 4. But I won't use that because I need numbers between 1 to 10 initially. So why would I choose my k equal to 4? I'll choose my number equal to this thing, the size of my array, so that whenever whatever number this generates, I can fill that particular number in my first index. Are you just getting my point? This function is already given to us, so we can choose any k. It will generate numbers from 1 to that particular k. But if we are having a number of cards, that is obviously 52 number of cards. So I'll choose my k equal to 52, so that I can get my numbers. That is, if I am using my indexes to swap the card, so I'll give input as 52, so that numbers between 1 to 52 are generated in each iteration.
Okay, now I understood your point. For a given problem, we'll take the maximum because we need to swap in the complete given range.
Yes.
My next question is, if you take a permutation between 0 to 52, how many times will you run that random function? That's where I wanted to know.
If Okay, so in the first case, suppose we run the 1 to k, it between 1 to k. So we are filling
Let's say
whatever
now k is 52. I just need to know how many times you are calling this random function.
this. That's not fixed, because whenever there would be a copy, then we need to call a random function once again in this particular solution.
So minimum it will be it will be 52
Minimum,
times.
it will be called at least 52 number of times.
Oh, okay.
All right.
I get your point now.
So this is not the perfect algo that we are talking about. This is just using extra space and a lot number of solution combinations. So what
What is
just
the complexity of this one?
what
What is the complexity of this solution?
for this solution, space complexity it would be that is 52 in this case. And time
Just
complexity, we are running.
what do you think, Komal? What will be the time complexity in this?
My understanding is if we are generating a random number between 1 to 52, that means I like if I assume that it is running in random function is giving me an O of n, it's scanning through it and picking up one. Then for every time I'm calling that random function, it's going to be the O of n, right? It will be O of n square, right?
No, random function in this random function generates a random function in O of one time.
Okay, so then I am calling that function equivalent to the number of maximum array, which is 52, right? So I can be given any number n. So then why
Yes.
are you saying it's not linear time? That's my question.
Why it's not linear time? Because that function is not going to be called exactly once. So suppose when half of the array is filled, so numbers will be generated when we need to call random number again and again.
Then you are saying it is equivalent to, like, we run into collision for hashing, so we will run into collision. That's why you're
Yes.
saying.
So suppose only just last two indexes are left, that is 51st and 52. So it's not possible for that particular random function to generate only number 51 and 52. It will be generating many random functions. So that's not going to be offline.
So now,
Akshit says the probability of having a collision that a permutation will be same is 1 by 52 factorial. Is that a correct probability, Akshit?
one
It
second, 1 by
seems
52
very
factorial. So there are
is
52 factorial combination. 1 by 52 factorial is when we don't we don't. So it's the possibility of,
Getting the correct solution in the
it's
one
the
in one go.
possibility of choosing the right number. Okay, we will watch the video. Okay, fine.
So
Let me
1 by 52 factorial is the probability of getting the correct combination in just one go. That random number
that
generates the exactly perfect solution. So there will be total
that makes
52
sense.
factorial possible combinations, but we need that just one combination which is perfect.
That makes sense.
But that also I don't. Let me see.
okay.
No, we can have any
I
number.
will watch the video and see what's the. I think complexity is increasing as you are saying. It's like the first one is easy to say, but later on, after half, I think the collision will be definitely more.
Yes, it's not open definitely.
But we still don't know what's the complexity. Okay. I mean, I will see. Let's see.
So
I think we need to write some mathematics here.
Yeah.
I guess that's going to be exponential. Maybe.
Yeah, you're right. Actually,
Yep.
it will be
Yep.
exponential. Yeah.
So let us move to the Fisher-Yates algo that Akshit already has written that select a number between a range 1 to k and start swapping with some random j or index. It will give you a random permutation that is equally likely. Do we need extra space? That's no in this case. So in this case, what we'll be doing is, so let us just take in first of all the array of 1 to 10. So what we'll be doing is we'll generate a random number. That is, we are having a random function.
Thank you, Ashmeet. I took a lot of your time, so I forgot to
Right.
start.
So here we are having k as 10. So it will be throwing us the numbers between 0 to 9, or sorry, 1 to k. So 1 to 10 numbers are given to us. So what we'll be doing is, first of all, suppose we start from the last element of the initial array. So there will be some number that will be generated by this array. Suppose that is 7. So what we'll do is we'll swap this element with that particular index. So here was 7. So we swap them out. So here is 10. Here is 7. So then this pointer, which was just pointing to the last number, that will move to this position. Here we already had 9. Then again we'll generate a random number between 1 to 10. So it can be anything, that is suppose it is 2. Then we'll just swap these two numbers. So here comes 9 and here is 2. Then comes the next number. Here was 8 initially. So again, this, if here we even have a collision, suppose again number 7 is thrown. So if it gets swapped with 10, that is 8 comes here and 10 comes here, that won't be a problem because this still is happening with the same probability in each case. So we'll be having totally a random deck of cards which will be shuffled. So at end, what we'll be having totally random numbers at each place. And this is the solution because in this case we are just running the loop once, and this would work in O of n times because random function generation has time complexity of O of 1. So do anybody have doubt in this case?
Can you explain like what if we run into like give random function gives same number again?
So that won't be a problem. So suppose till here that shuffling was going on totally correct. So here is 4 and the number generates 4 itself. So it would be swapped with itself, which means that still it will remain at its own position, but still the probability for each of the number getting swapped is remains same. So this combination will be still a random combination because still the
Okay.
probability was same because they have told us that random numbers throwing number 1 to 10 has the same probability for all of the numbers. because all the numbers are equal likely. So this swapping is also equally likely. Maybe it's a swap and maybe it's not a swap. So this swapping for any of the number 1 by 10 is the possibility that the number won't be swapped for each of the numbers. So that's fair. That's not an unfair thing.
Okay.
All right. Anybody else have any question? Is it clear that this is going to be just in O of n time, that is linear time?
Yep, that's a great explanation actually. You took a lot of time to answer the questions. That's
Okay.
good.
So let us move to a solution. So I'll be just doing the solution over here. So what the solution actually is. So first of all, we need to create a function. So here, already have a class. Okay. So what our function is, that is void shuffle cards. So here we are initially given all the values of cards. That is cards we are having, and integer, and we are having, which we are going to post as the number of cards, that is 52 in that case. So if we are doing it with 10, we'll pass 10 in this case. So if there are only 10 cards, we need to shuffle. But if we want to shuffle the whole deck, we'll pass it as 52. So then we need a random function to generate random. So I thought the question was asking us to design the whole deck of cards and then shuffle. Right, so we are here generating a random number. After that, we start loop. That is when r equal to 0 and so now here we'll be generating a random. We'll be using that function that is generate number that is getting generated. That will be I plus dot next. And we need to generate numbers between if we are ith index, then leaving the indexes that are already swept, we just want the all the other indexes to generate a number between. All right, so here it is I. So if you are beginning with the last position, it would be different here. If you are beginning with initial position, there would be a little difference in this position. So if I'm having an index 0, I need to just generate random numbers between these positions. So if my index is 5, so these first 4 numbers are already shuffled. I just need to generate a number between these, the next few combinations, that will be 5 plus, we are generating numbers. Suppose there are 10 number of cards, number between, that is random of next 5 numbers. So it will give us 5 plus some number, suppose 2. So we'll be swapping this with the 7th position. All right. So this is what I just did. That is 5. That was the initial index. I have generated the number between the left number of indexes, and I've added with the index to get the index with which I'm going to swap the numbers. That is 7 in this case. So that is same what I'm doing in my. So if I'm starting with starting from just the end of the array, then I need not add I to it, because we can simply generate and subtract the count that I have already shuffled, and the number will keep on generating between 1 to 51, 1 to 50, 1 to 49, and so. So now let us begin swapping. Okay. So let us create a temporary number to swap with. Start at position 1. Then this start at 2 is equal to start at I, and finally this start at I is going to be equal to temporary number. So we have done shuffling, so it will just complete the function. Now we just need to check whether we are right or not. Let us create an array. So let us have few values. That is, suppose I am going with these 10 values initially. So now I'll call my shuffle function. That is shuffle. So I'm going to pass my array and size, that is 10 in this one. So we have shuffled the cards. Now I need to print these numbers. Yes. Just So let's start on this. So here we are done with this. That is cards. That was line number 11. All right. Shuffle cards. So, all right, this would be working, I guess. No output. What does that mean? Exception in thread main Java dot index exception. What do you mean?
We are going out of the index of the array.
I is equal to 0 till I less than 10. How can that be?
In which line we are going?
You
Can
are
you?
checking for 10 numbers and you're given an index from 0 to 52.
What?
You're checking for 10 numbers and you're giving index from 0 to 52. It should be 10 minus I.
All right, yep.
Yeah.
Okay. So here is some random list. So as you were just talking, that in this case, that 10 is swapped with itself. but still we'll call it some random generation. If we generate once again, then again we encounter with some different C. In this case, that is 4852. So it might be possible that it is swapped with itself, but that is possible in this deck of cards that we need not shuffle each of the cards. Maybe some of the cards are swapped, and maybe two or three are yet not swapped. So this algo is the Fisher-Yates algo. So, and this works in O of n time. And another we just discussed that is we can use a separate array and keep on shifting values to that. That I don't call as that is not yet that good. So this is what we just discussed. If anybody has any doubts regarding this question, just ask. Guess it's pretty easy to understand. Okay, so now we'll be moving to the next question in next 2 to 3 minutes. The next question which we are going to discuss is the tic-tac-toe game. In that we'll be having two players, and we'll be finding which player won the game after how many number of moves. So that's all for this question. So next 2 minutes we are going with the next question. Thank you.